Welcome to Programmable Logic Controllers, a tutorial. My name is Steve Grotta, and I have over 40 years experience programming PLCs, robotics, automation, and general automation systems. This tutorial is designed to impart basic knowledge and give you an idea of how systems work and what is the core elements that you need to understand in order to make a system. So good luck, and hopefully this will give you the knowledge you need to provide yourself with a well-designed and well-programmed system. In this synopsis, Module 1, Chapter 1, we'll go through vocabulary, definitions, terminology. Module 1 will also consist of numbering systems, understanding the differences between binary, hexadecimal, octal, and decimal, and conversion between systems working in a system. Module 1 also includes basic electrical circuit theory, electron flow, Kirchhoff's voltage law, Ohm's law, DC versus AC, single phase, three phase, a cycle, and square waveform timing charts. Module 1's goal: answer the following question. What do you hope to gain from this course? There is no right or wrong answer here, only what you want to get out of this. Louis Pasteur said, "Chance favors only the prepared mind." Being prepared for as many possibilities allows the programmer technician to safely navigate the world of PLCs. PLC Programming, Module 1, Chapter 1. Vocabulary and terminology. PLC is an acronym for Programmable Logic Controller. It's a device that takes real-world inputs, processes those inputs logically through a series of sequential programming steps, and affects output to the real world based upon the outcome of the programming logic. A scan is one complete cycle through the program. An input is a digital representation of a device status in the real world. On or off conditions are associated with the status of the device circuitry. An output is a physical manipulation of a real-world device. An I/O update is the reading of inputs and setting of outputs in a single scan of the program. Discrete. It describes a unique location in physical memory that represents an input or an output. It could also represent a register or any other type of input, analog, etc. Analog, a signal having a voltage or current level that represents a scaled value. Digital, a signal that has a defined on and off trigger point that sets a corresponding representation in the memory location associated with the signal. A sensor is a real-world device that, when triggered, sends a signal to another device in a predetermined way. PNP, a type of electrical circuit typically known as voltage sourcing. The circuit voltage is switched on or off in this type of circuit, and the load is connected to the common or ground. NPN, a type of electrical circuit typically known as voltage sinking. The circuit's common line is switched on or off in this type of circuit, and the load is connected to voltage all the time. I find that this is a dangerous type of circuit in outputs, and I'll explain that later on in the course. Sync. This is a term used to describe what happens to the voltage or current depending on the type of circuit. In a voltage sinking circuit, the voltage on the load is connected to the ground or common, completing the circuit. Source. This is a term used to describe what happens to the voltage or current depending on the type of circuit. In a voltage sourcing circuit, the voltage is switched on and off to a load connected to common or ground. Voltage. It's an electrical term for the amount of potential that exists in a circuit. Current. An electrical term for the amount of amperage that a circuit will draw. Short circuit. An electrical term for a condition that provides a perfect electrical path between 2 points of connection, i.e., no resistance to the flow of electrons. Ampere is an electrical term for the unit of measure of current in a circuit. An ohm, an electrical term for the unit of resistance to electron flow in a device, wire, or circuit. A watt. A watt is an electrical term for the measure of power defined as 1 joule per second. Normally open. A term that describes a device or discrete signal that is not on or conducting power in the rest condition. Normally closed is a term that describes a device or discrete signal that is on or is conducting power in a rest condition. Normally open, held closed. A normally open device that is mechanically or by other means made to conduct in a rest condition. Normally closed, held open. A normally closed device that is mechanically or by other means made to not conduct in a rest condition. A one-shot signal. A one-shot is a signal that exists for one scan of the PLC program. Ladder logic. Ladder logic is a programming language or style that presents the programmer with a method that resembles the rungs of a ladder, i.e. electrical schematics. A rung is a single circuit of program language in the ladder program. Coil. A representation in the ladder program of an output. Coils can be used or tied to real-world outputs, or a coil can be an internal signal with no real-world affiliation. A bit. A single memory location in the controller. A bit can have a discrete nomenclature. Byte. A collection of 8 consecutive, boy, let's try that 3 times, consecutive bits that are associated or grouped to form a memory location. Word. A collection of 16 consecutive bits or 2 consecutive bytes grouped to form a memory location. The word has a lower and an upper byte. Double word or D word. A collection of 32 consecutive bits or 2 consecutive words to form a memory location. A double word has an upper and lower word, and each has 4 upper and lower bytes. Register. A specialized word or words in memory associated with specific programming instructions. Timer. A function of the clock frequency of the controller that is converted to time, represented usually in seconds or smaller increments. Counter. A system function that allows the transition of the enabling logic to store iterations of the transition in a decrement or increment function. Retentive. A condition that is kept in a steady state through a power cycle or reset of the controller. Non-retentive. A condition that resets upon a power cycle or reset of the controller. Battery-backed memory. an area of memory that is preserved during extended power removal through a battery. Series circuit. A circuit that has two or more components connected to each other, with the first component passing power to the second, and so on. Parallel circuit. A circuit that has two or more paths to the load. Each path may be a series circuit or a parallel circuit that is nested. Nested parallel circuit. A circuit that has a path within a path, which may be a series circuit branch. All of that sounds very confusing, but will be explained later. Logical AND. A logical AND is a programming representation of a series circuit. Example, if switch 1 and switch 2 are both on, then do something. Logical NAND. A logical NAND is a programming representation of a series circuit. An example would be, if switch 1 and switch 2 are both off, then do something. Logical OR. A logical OR is a programming representation of a parallel circuit. If switch 1 or switch 2 is on, or both are on, then do something. Logical NOR. Logical NOR is a programming representation of a parallel circuit. If switch 1 or switch 2 is on, or both are on, then do not do anything. Exclusive OR. A programming method of ensuring a unique set of conditions exists between two inputs. Example, switch 1 is on, but not switch 2, or switch 1 is off and switch 2 is on, or both are on. Exclusive NOR, programming method of ensuring a unique set of conditions exists between two inputs. Example, switch 1 is on, switch 2 is on, or switch 1 is off and switch 2 is off. Here are a series of charts that show the logical outputs and inputs for the different types of gates. So if you look at the AND gate in the upper left corner, if input A is a 0, input B is a 0, then output is a 0. If input A is a 1 and input B is a 0, then the output is a 0. Likewise, if input A is a 0 and input B is a 1, the output is still a 0. But if input A is a 1 and input B is a 1, then the output would be set to 1. You can go through and look at all the different logical outputs based on the gates and get a feel for how that works. If you look at the inputs as real-world devices, a switch, a sensor, any type of other real-world device that you can think of, i.e. a wired to an input on the PLC, then you can start to think how you would logically control a PLC's program and affect real-world outputs. A NOT condition. The discrete opposite condition of a signal. Signal A is on, then signal A not is off. A chart showing this as a logical representation: when input A becomes high, input not A becomes low, and vice versa. Module 1, Chapter 1 is now complete.